How's it going, everyone? Welcome, Gabriel Gonzalez here, and today let's going to talk about is the closure part of this chapter three. The getting started in this series of books written by Kyle Simpson, a software engineer with over 20 years of experience. That he now uh, uh, wrote this book in 2019, and I deeply appreciate that he did that. So I can have a sense and an understanding of how do I get here. So in the chapter one and the chapter two, in the chapter one we talk about is what is JavaScript, all right? I'm not going to dive deep into that. And then serving JavaScript, all right? Things like how JavaScript C programs, what a program is, and what we can do with programs, which is showing values. What kind of value can we have? Primitive and objects. In objects, what is an object? Uh, in what are the type of object that we can have? So, for example, it's array, object, or functions, and how functions are also a value known, and this is why we know this as the first class citizens. Okay, and how can we now is determining the value of a type? How can we describe values, whether it's a literal or variables, held into these containers that has several syntax form, whether it is the var, let, and cons, and each one of them has as a particular behavior, and also you can define them via functions declarations, or inside of a functions parameters, or in the try catch block. And we also explore what is a function, what is the role on JavaScript, right? So whether it's a procedure and the mathematical definition of a functions, and how can we define is a function, and what happens when we do that, all right? The association between the identifier and the value happens is at compile time, parse time, and the in the function expression, which is when you use now a function as a value held in a containers, how this happen is at runtime. So because of this difference, which is something that we're gonna see that later on, right? How can we use now variables in other data structures as values that open up is a new world of possibilities? And how can we is compare different type of values? How can we convert different type of values known as coercion? And what is the different edge cases that happens, and how now the language actually compare values, not by its content, but by its reference. And how when it comes to organize our code, we have the traditional ways, whether it's using models as a function, or as a function immediately invoking function expressions, or as a this ex6, which is using import and export, right? And we also have is classes as well, and how now classes is at the end of the day, which is allowed to describe is this custom type of data structure that has its own data and its behaviors that we can operate on that data. So all of this is just to now briefly describe is chapter one and chapter two and now chapter three, which is digging into the root to understand is this intrinsic characteristic of the JavaScript language that allow us is to use them, and a lot of the time they are now uh, they are now part in every line of code, virtually in every line of code that we write. Okay, so because of that, we look at the iteration, and that makes a lot of sense when he described that, because iteration, which is part of the so iteration is the way on when we talk about iteration is because programs a lot of the times they consume data to process that, to make some decisions on that, right? So because the way of how, because the algorithm we use to uh, describe is this iteration protocol, uh, must be something that can be read, must be a readable code, because what happens is that if you don't have that, so every little program that wants to consume data one chunk at a time, implement their own, which is one of the reasons, for example, that it's become quite a nightmare to maintain. So all of these patterns, for example, like the iterator pattern, which say, hey, this is the standard way when it comes to consume data from a huge data sets, one chunk at a time, okay? So, and to do that, the language here in itself say, hey, this iterator that has a reference, it's a data structure that has a reference to the underlying data source that is going to describe is the how do you call it? Is going to describe an algorithm. Or is going to this iterator pattern, right? Describe is this iterator data structure that uh, has a reference to the underlying data structure or the underlying data source, and that expose is a method called next, that when we execute that, it gives us now an object with the done and the value. When done, it say, hey, we reached the end of this data source. And you can think of this like a rows in a table when you want to consume that, for example, in a database, and then each one of those rows, as you consume that, or you want to held in some variables to act some or to do something with it. And because with this function or with this pattern, right? In JavaScript, the way how now can we is consume variables using now this iterable protocol is as long as those objects has this iterable protocol implemented, and they do that when when in their properties they have this definition of the yeah they have this definition uh, in their properties. So for example, or along the prototype chains. So for example, is the symbol.iterator, which is one of the reasons why we use now symbols, is to held some hidden values that we don't want to expose, that this whole is a reference to this protocol and indicate that, hey, this data structure, this value now can be iterated over. So for example, strings, arrays, map, sets, among other data structures, right? And here you can consume that is using a special syntax that is going to recognize, going to ask for those objects that you want to iterate over. Uh, if that contains that implementation. If it is, good. Now, when you use the syntax, the for of, all right, is going to consume that for us. So we have now is the, let me see if I can take a look at this, the of syntax, syntax form, no, there's a mention. What about the for? Exactly. There you got it here. This is part of the iteration statement, for statement, and there you got it. Here is the for in and the for of and the for away for of a statement. Look at this. It is in the statement iteration as part of these statements and declarations. Mm. Mm. Okay, in the section 14 is when we have the statements and the declaration. And here we're describing is the expression. Okay. So in the statement, all right, makes sense. So when you have now the statement, the block, the empty, the if, the iteration statement, also the continue, break, return, with, switch. But in our case, what we care is the iteration here. So for example, the iteration statement that it can be is the while, for statement, and for in statement, which is this new way of doing this. All right, that you can define for in here. It can be a curly or square brackets and left hand side expression for this expression. So you can have is int, whether it's you use that with let or var, or with this, or with the for of an assignment expression. The same for this, and the same for this. For a wait, okay, as a way to not consume this iterables for a wait. So let's take a look now briefly at the for of, the for in, and the for of, like this. The for in tell you this. All right. And the for of is this. Here expected now an iterator record, iterator kind, the for of and the for in. And the for of is expecting now an iterator as well. There are some early errors here that it say. It is syntax error if its label function statement is true. Static semantic is the structuring. But I do not want to read today is the spec. I just want us to move on to this topic, which is the closure. All right. Which I do find that this is much more convenient because I not only want to talk about is the closure, but also perhaps moving to the this keyword and the prototypes again, just to make this huge overview. But if we recap this iterable, right? That's what we look, right? So this is standard way or these conventions that say, hey, if we want to consume a huge data source, one chunk at a time, this is how we do. And in the case of the EXIS, in order to consume those data source that implement, or the data structure that implement, or those values, okay? And I want to stick to the value to say, hey, that a value can be is, well, not only a primitive, but also an object, and functions as well, an array, okay? So This is the convention when we want to consume is this kind of values, okay, one chunk at a time, and it's going to expose now this iterator data structure, uh, a certain methods or the next method that when we call this function we're gonna get the value and another property called done to see if we reach to the end of this collection. And because in EX6 the way of how we can consume that is using is this special syntax, the for of or the spread operators, and in the spread operator we look at that it's going to call that if that particular object contains now is the symbol or if that particular value contains now is a reference to this protocol, to this data structure, to the iterator via the symbol dot iterator. And if it is, makes sense. Let's go to now actually is, well, call this next functions until we reach the end of that collections, right? So this is what we have is the for of loop. And then is the way of how can we now, or the different values that we can iterate over, which is strings and which is strings, maps, sets, arrays, among others. Okay, and even in objects, which is something that they don't mention here, but because most part or most for most part all built-in iterables in JavaScript has these three iterator forms available, like the key onlys or the values only or the entries. Okay, this is how we can now consume those iterators, okay, via the iterables. And the iterables is just a data structure that say, hey, we can iterate over it, all right? And this is the difference between the consuming iterator and the iterables. Remember, iterators are those who are implementing this contract that when we want to consume those iterables, which is data structure or values that we want that we can iterate over, they have, right? So when we look now at the closures, right? Perhaps without realizing it is almost every JavaScript developers has made use of closure. In fact, it's one of the most pervasive programming functionality across a majority of language. It might even be as important to understand as variable or loops. Ooh. Mm. That's how fundamental it is. Yet it feels kind of hidden, almost magical, and it is often talked about in either very abstract or very informal terms. Exactly. This is one of the things that happen with me with closures, right? Or they are either talked about in abstract or very informal terms, which does little to help us nail down exactly what it is. We need to be able to recognize where closure is used in programs, as the presence or lack of closure is sometimes the cause of bugs or even the cause of performance issues. So let's define closure in a pragmatic and concrete way. So my current definition of closure is that is variables that we can have access, uh, but it is that is variables that we can have access even when that function was even if that function is execution, There are variables that we can have access even when that function is executed in a different scope, right? Later on. But it's talking about is variables. Variables that can be stored or remembered somehow in in act so variables that we can remember somehow even after the function is called in a different scope, right? So here we have closure is when a function remember and continues to access variables. Oh, but we're talking about now is the function from the perspective of the function. In my case, from the perspective it was from the variables. Okay. So closure is when a function remember and continue to access variables from outside its scope, even when the function is executed in a different scope. So even if this function is executing in a different scope, a closure, okay, and when you talk about it in a different scope, whether it's a function inside of another function or inside of or a block, this is what we need to define is what is a scope here, right? What the language recognize and say, hey, what is a scope here, right? What does it mean a scope? But no, scope analysis. Scope analysis. What about that you have that scope analysis, instance operator. But it mentioned is this scope analysis. The syntax direct operations bound names. Bound names takes no arguments and return a list of a string. Oh, it is bounding names. It is used within this specification as a synthetic name for a model's default export when it does not have another name. An entry in the model's environment is created with that name and holds the corresponding value. In the model's environment is created with that name and holds the corresponding value, and resolving the export name default by calling resolve export name resolve yet. For the model will return a resolve binding record whose binding name is default. Resolve binding records whose binding name is default, which will then resolve in the model's environments to the above mentioned value. This is done only for ease of a specification so that anonymous default export can be resolved like any other export. And this default string is never accessible to ECMAScript code or to model linking algorithm. But this is when it's going to bound names. So I want us to go over this, perhaps read this in the next chapter or in next videos. But this is what I want to do here is to get this notion of the closure, remember what a closure is, and when is a functions remembers and use or it can have access to is when a function remembers and continues to access the variables from their outside scope. Okay, from the outside scope, even when that function is execution, even if that function is executed in a different scope. Okay, so we see two definitional characteristics here. First, closure is part of the nature of a function. An object don't get closures. Functions do. So you can have access to the outer, okay, functions do, objects don't. So you can have access as a function uh, via closure to the outside. Uh, exactly, you can have access. Okay, so in other words, you as a function, you can have access to these values that are held in these containers, aka variables, and access to that even if you as a function was or is executed in a different scope. If this function can be executing inside of another function scope, or inside of another block scope, or in the global scope, which is the only scope that we know so far. Maybe there might be another, but at least this might work. So this is the formal definition of a closure, right? Um, and it makes sense. Okay, so uh, the two definitional characteristics here is the closure is part of the nature of a functions. So objects don't get closures, but functions do. And second, to observe a closure, you must execute a function in a different scope than where the function was originally defined. So you're talking about is two things. So closures is per functions. It is like a feature of the function, and it holds those values or those variables in a different scope when they was executed. So you must execute a function in a different scope than when the function was originally defined. So consider this. So you have this function, all right, and this another function that is returning by that, right? And here you have now the message, the name, and you're going to actually do this kind of stuff. So var hello, which is now globally or function scope, it says, hey, I'm gonna invoke this, thanks to these parentheses, with this argument. Okay, this is the value, and I'm gonna call this another one. Inhale that value, which is a function, here. Okay, so both of this now contain is a reference to this function. All right. So when you call this hello or howdy, right? You can now is print this thing. First, the greeting outer function in this case is executed, creating an instance of the inner function who. Okay, so when this function is executed, it creates now a function execution context, a new branch execution context. All right, that it will create an instance of these functions. So that functions, the function who, close over the variable message. Exactly. So this function that is returning here is closing over the variable message, which is the parameter from the outer scope, greetings. So when the inner function is returned, it is referring its assigns to hello variable in the outer scope. Exactly. So when the inner function is returned, it is referring its assigns to hello variable in the outer scope. So then when we call greeting a second time, which is creating the inner function instance with a new closer over, a new message, and return the reference to be assigned to howdy. Whenever the greeting function finish running, normally we will expect all of its variables to be garbage collected. Okay? Which is that. So whenever the greeting function When the greeting function finished, normally we will expect all of its variables to be garbage collected, removed from the memory. So we expect each message to go away, but they don't. The reason is closure. Since the inner function instance are still alive, since the inner functions instance are still alive, because they are held here in this container, okay, their closure are still preserving the message variables. These closures are not a snapshot of the message variable's values. They are a direct link and a preservation of the variable itself. That means closures can actually observe or make updates to these variables over time. So because they held the variables, so because closures allow functions to hold the variables from the outer scope, okay, even when the function is executing in a different context. So those variables that normally when you run a functions, they are now garbage collected, right? But they don't. And these closures are not exact. These closures are not a snapshot of the message variables value. They are a direct link and a preservation of the variable itself. That means closures can actually observe or make update to these variables over time. So for example, in this case, we are calling as this function, okay, with the step 1, and we are calling this another function with step 3, okay, and in those cases we are assigning is whatever is returning as inc by 1 and is by 2 inc by 3 respectively. So this return functions increase counter. All right, what it's gonna say is, hey, I'm gonna return is this reference, but since this function is now access to these outer variables, so it's going to hold those values. It's going to hold those variables here. It's going to preserve those variables here, right? Whether it's a step and a count here. And here in these functions, it can now have access to those variables from the outer scope, even after, exactly, they can have access to, so this can, so the functions can have access to the variable in the outside scope, even when they are called, in a different scope. In this case, they are calling into a they're calling is here in the global scope, right? You can call it in a different scope, in a function scope, right? Or you can call it, so for example here, take a look at this. You can either call this counter here as it is, all right? So you can either call this function counter here, all right? Or you can say, hey, I want to create a new function. Let's say this is a model function, right? That is in here, that I want to now is create this, right? And then I want to say, hey, inc by 1, so I'm calling it in a different context, all right? Here we're not going to pass anything as it is. In fact, I just want to say something like this. And by the time I call now is the model, the model function, okay, that is gonna be executed now. So it means that we define as a functions declaration, which is now the association between the identifier and their value happens is at parse time, okay. So this is why, for example, if you define is this, let's say this. So if you define for some reason is, yeah, well you get the idea. You get the idea. This actually will work, right? You get the idea. So the point of this is that instead of defining is the functions definition here, if you say, hey, I want to assign is a var, and say something like this, all right? In this case, come on. This is the model, okay. So if for some reason we say something like this, all right? And then later on we define is counter, because despite that this counter variable is gonna be hosted, all right? The question is, its value will be hosted, okay? So the association name will be hosted, but its value will be hosted? I'm thinking yes. In line 11. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11. Oh, yeah, you are right. There you go. I do think it is, exactly. So not only this, look at this. So what happened here is that var and functions declarations, not only the association between the name and the identifiers, or the identifier and their value happens is at the compile time, all right, their values as well. This is why this actually works, you know. This is the reason why it actually works. But if for some reason we define this as a let, I do think that this let counter has already been declared. You are right. Okay. So what about now? Exactly. It says with var, yes, but with let, I'm not hosting this value. This is lexical. This is lexical. Interesting. With let, I'm not hosting this identifier and their value, and this is lexical. Okay, this is lexical, and the same for cons here. Of course, it's not gonna work, right? But if you do something like this, it's a reference error counter is not defined, because at compile time or parse time, that hoisting never happens. So JavaScript doesn't know that reference. That's what it tells you, this reference error. Counter is not defined. So I do think that this is quite interesting, and also to understand more about is the nature of this syntax form for real, okay? So when you have this closure, we talk about this, especially here, right? Each instance of the inner increase count functions, and each instance is any time that we call now the counter. So each instance of the inner increase count function is close over both the step and the count variable from its outer scope counter function scope. Step remains the same over time, Exactly. Step remains the same over time, but count is updated on each invocation because we're returning is the count. Since closure is over the variable and not just a snapshot of the variable, okay, so closure is over the variables and not just a snapshot of the values. These updates are preserved. It's over the variables and not just a snapshot of the values. So closure is most common when working with asynchronous code, such as with callbacks. Consider this. Mm, mm. With asynchronous code, get some data URL, and then I'm gonna execute this function. Here, I'm not returning this function. I'm executing is this function, right? And I'm gonna pass it the URL, and similar for the function on response. So Ajax is creating this new function execution context. When that function is called, that is going to pass the URL as a parameter, and a function's definition and a function's definitions here. So this, the association between the identifier and the bindings happen is at compile time, all right? So in other words, if you define, for example, is this, all right? Ajax, of course, is not going to work because you say, hey, I don't define. I know. Do you have any Ajax here? I don't believe it. Ajax is not defined. Exactly. But by the time I call, they get some data. You say Ajax is not defined, so it makes a lot of sense. So we can do something like this and say, hey, let's go to define some Ajax function, Ajax function. Where these Ajax functions here, it'll be Ajax, Ajax function is URL and a function, right? And what I want to do is to now inside of this is just call that function, right? Execute that function. Execute that function. Yep, execute that function with the URL, right? But in this case, execute that function with the response, which of course it will be is undefined, right? Period. Okay, so by the time that we call that function, okay, get some data with some URL, some HTTP, loading Ipsum, yada yada, it's a reference response is not defined. Oh yeah, you're right. Yeah, because we're not passing any reference to this, just it's gonna say this one, okay? And that's what happened, right? It's a response from URL, and the response is that, right? So we can also say something like this, say, hey, this function would say, hey, static response, static response, right? So you have from HTTP, you say static response. So, but the thing here is that by the time that we call this function, we not only is passing is the URL, but also is we passing is a function's definition. And because we are doing this, because we're defining is this function's definition here, is also going to close over not only when the function is returned, but is if that particular function, not only when the function is returned, but if that particular function have access to the variables in the outside scope, that so not only when the function is returned, which was a fallacy, but also is when the function is declared as a as a as a as a as an argument in a function, right? So anytime that you're defining is a function here, this is why it focuses on the functions. So closure is when a function's definitions or a functions remembers the remembers and continues to have access to the variables from the outside scope, even when the function is executed, or even when the function is executed in a different scope. It makes a lot of sense. Even when the function is executed in a different scope. So this function will be executed not here, is when data is called. So for example, get some data here in this global scope, or it can be in another function scope or in a block scope, you name it. But okay, so far, according to this, is so far about the functions definitions, and if that functions have access to those variables, and if it is, then you are effectively creating is a closure. So the inner function on response is close over URL here, and thus preserving and remembering it until the Ajax call returns and execute on response. Even though get some data finish right away, the URL parameter variable is kept alive in the closure for as long as it needed. It is not necessary that the outer scope it's not necessary that the outer scope be a function. Interesting here. It usually is, but not always. Just that there be at least one variable in the outer scope access from an inner function. So for example, in this case, is not only for a functions, but it's not exclusively for functions. Usually it is, but not always. Okay. So because this loop is using let declarations, each iterations, the block scope, aka the local, right? The block scope, the index and the bottom variables are passed to that, right? Or each iterations because we're using is let, each iterations gets a new block scope of index and the bottom in this case, because we're using is let, and let now allows to define variable in the block scope. Getting is now on each iteration is the index and the bottoms at that moment. So the loop also creates a new inner on click, okay, because it's not only is calling this, and the loop create is an inner on click function each time. Is defining that function. That inner functions close over the index only in this case, it can be also for the bottom, but we don't want that. But that function close over is the index. Preserving is as long as the click handler is set on the bottom. So as long as the event handlers, so as long as the click handler it's set on the bottom, it's going to preserve that. So when you now remove the event listener is when that reference are removed. In other words, is when those functions that you attach to these event listeners are going to be candidate to the garbage collector. The loop also creates a new inner onClick function each time, and that inner functions close over the index, preserving it for as long as the click handler is set on the bottom. So when each button is clicked, all right, it is handler can print it is associate index because the handlers remembers its respective ID variable. Remember, this closure is not over the value like 1 or 3, but it's over the variable itself. Closure is one of the most prevalent and important programming pattern in any language, but that's especially true of JavaScript. It is hard to imagine doing anything useful without leveraging closure in other way or another, in one way or another. If you're still feeling unclear or sharky about closures, the majority of the book 2, Scope and Closures, is focused on this topic, which is something that we're going to see that in next videos. So closures is not exclusively per functions, all right? Is anytime a function have access to a variable from an outer scope, it remembers, okay? It remember it even if the function is executed in a different scope. So it is all about the functions. And remember, functions are values. It's this set of instructions that we can have, that we can held in a container and then execute it. So it makes a lot of sense that closure, okay. So closures is when a function remembers and still have access to that variable, exactly, still have access to that variable from the outside scope, even after the function is even after if the function is executed in a different scope. Okay, not only inside of the functions, but also is in any time that a function anytime that when you're writing your code, have a reference, or when you read a code from somebody. So anytime that that function have now that particular reference of the code, all right? So anytime that somebody have that reference, so anytime in a function's declarations, you define is a reference, or you define is, or you use, all right? You use is a variable from the outside scope. It's gonna create from exact. So anytime in a function's declarations, you use a variable from the outside scopes, so JavaScript remembers that variables even after the function is executed in a different scope. whether it is inside of another function or inside of a block or even in the global scope. It makes a lot of sense, but it's from the point of view of the functions. Okay, so when you're doing this kind of stuff, so the index here, it'll be now store that no matter how many times that you should click there, all right, as long as so the function on click is closing over that variable, aka is remember that, all right, until that click event listener in that element is removed. This is why this is when the memory leaks happens. Holy because this button, all right, all of these buttons now hold all of these handlers, and when you click on them, so they are going to now is not only show you that ID, but also is store that reference. And if that reference continue to grow per button, okay, so there is a point for them to crash, because now JavaScript doesn't have enough memory to represent that variable. So I want to actually put a test in my understanding here. I want to put a test in my understanding. Yeah, let's get into this. Let's get down to business. We got a million, we got a things like this. Let's get down to business. Holy perfect. And we're back. Okay. Jesus, French those guys. Okay. Okay. So it is safe to say that since closures is when a function remembers, and continue to access variables from the outer scope even after the function is executed in a different scope, in this case, in this case, the the function on click is closing over the variable idx from the for of loop, since let create a new fresh index and bottom values. See, it creates a new fresh index and bottoms values that are passed into the block scope. So if for some reason a user if for some reason if for some reason we have too many buttons index, if we have too many index created attached to the if for some reason we have too many index created if for some reason we have too many index created, because the point here is that if for some reason we have too many index created, right, this could lead to a potential memory leak, since the idx is preserved. With only percent as long as the event listener exists. Exactly. When the bottom element is removed from the DOM and properly cleaned up. Exactly. When the bottom element is removed from the DOM and properly cleaned up, an event listener get garbage collected. Primitive values index is just a number primitive. Exactly. So memory overhead per closure is minimal. It is not like you're closing over large objects or DOM reference. For example, if you have now large data that you want to fill in somehow. Exactly. In this case, this functions is gonna keep alive is all of the functions, all of the variables reference from the outside scope. Large data and DOM ref. Document the query selector dot some element. Problematic closing over large objects. Best practice to avoid, always remove event listeners when elements are destroyed. Be mindful of what you're closing over. Avoid large objects when possible. And use weak reference or cleanup callback when dealing with large complex data. Use weak reference when dealing with complex data structure. Your understanding of flow is spot on. The potential memory concern is valid in principle, is less likely. Okay. All right. Okay. It makes a lot of sense here. Okay. All right. All right. Okay. Cool. Cool. All right. It makes a lot of sense. Okay. But that is per functions. No matter in which, no matter where you define a function, okay? So no matter where you define a function, you are going to create a closure over variables if that function use that from the outer scope and then execute later on. And this is something that is heavily used, man. We usually, oh my god, so we usually create is this. Holy fuck, we usually create this without even knowing about that. Good. The other is like this keyword. One of the JavaScript most powerful mechanism is also one of the things most understood. That this keyword, and one common misconception is that function this refers to the function itself. Because of how this works in other languages. Exactly. But this is how this works in other languages. Another misconception is that this points the instance that the methods belongs to. This points the instance that the methods belong. This points the instance that the methods belongs to. Both are incorrect. So one common misconception is that the function this refers to the function itself. And it's not, as we can see there. And because of how this works in other languages. Another misconception is that this points the instance that the methods belongs to. Both are incorrect. Really? As discussed previously, when a function is defined, it is attached to its enclosing scope via closure. It is attached, when a function is defined, it is attached to its enclosing scope via closure. Scope, it is attached to its enclosing scope via closure. Scope is a set of rules that control how reference, here we go. So scope is a set of rules that control how reference to variables are resolved. How the reference of this container is resolved. But functions also have another characteristic besides their scope that influence what they can access. This characteristic is best described as an execution context. The characteristic of what the function can have access. The function also have another characteristic beside their scope that influence what they can access. What they can access. So not only that the function also describe is their scope, okay, this set of rules of that this set of rules that say how how reference variables, or how reference to variables are resolved, but also what it can access to. And this characteristic is best known as the execution context. Okay. And it is exposed to the function via this keyword. So what this function can have access. So this feature is described as the execution context, and it is exposed to the function via this keyword. Scope, it is static and contains a fixed set of variables available at the moment and location you define a function. Scope is static and contains a fixed set of variables at the moment and location you define a function. But a function execution context is dynamic, entirely depending on how it is called, regardless of where it is defined or even call form. So it's how it is called. This is not fixed characteristic in how you look at how it is called. How do you define that? This is not fixed. This is not a fixed characteristic of a function based on the function's definition. This is not a fixed characteristic on the function base of a function based on its function's definition, but rather a dynamic characteristic that determines each time the function is called. So the value that a function can have access, okay, or what can a function have access, is a feature determined by is a feature described as a context execution. Let me take a look at this. This is true. The context, this case here, the execution context, I think it is, but the so what so it is safe to say what a function can have access, okay, what a function can have access is described oh my god. Okay, what a function can have access is described is described as an execution environment, right? Or as an execution context. In JavaScript, can you point me where in the doc says this? Okay. So what a function can have access is described in the execution context. So you have the execution context and you have the functions in the execution context. The official ECMAScript specification MDM documentation does not define execution context simply as what a function can have access to. Here's what the authoritative source actually says. From the official ECMAScript specification, the spec defines execution context as the abstract concept used by ECMAScript, by the language, for typification and differentiation of an executable code. Ah, but this is Dimitri. Wait, what? And state. This is in 2010. Holy French toast. Dmitry Shoshnikov. Oh man, holy crap. Programming language, Ultimate 3rd edition. Building a transpiler from scratch. Programming language with LLVM. Oh, and they have all of this on Udemy. Building a virtual machine, building a parser from scratch. Essential of parsing, algorithm. Essential of interpretations. Essential of garbage collector. Holy fuck, who are you, bro? That's quite interesting. And teachable. Dmitry Soshinov education. Oh, and exactly, they have its own things as it is. 2025. Building interpreter from scratch. And compiler engineering path. Oh, but this is compilers. Okay, holy French toast, bro. Do you have any other things? Dimitri, an engineering manager interest in learning and education. I blog on topics of programming language, compiler, parsers, and advanced JavaScript. You can find my class in here or here in Udemy. For the latest update, you can follow me on Twitter. If you find this content helpful and useful, you might also support the project. Okay. Dmitry Soshhinkov, software engineering and instructor. In Udemy. This changed a lot. Okay. Automata theory inside of regular expression machines. Parsing algorithm, building a types checker from scratch. Oh, but this is very low level stuff. Building a virtual machine for programming language. Building a parser from scratch. Building a parser from scratch here.
Hi and welcome to the first session of the Building a Virtual Machine class. My name is Dmitry Soshnikov and I'll be teaching this class. And just to say that
functions and call stack, closure implementation, garbage collecting, object programming.
agenda, this is purely practical class. We will discuss just few amount of theory, however most of the lectures will be actual practical exercises, right, building a virtual machine from scratch. And for those of you who have taken the Essentials of Interpretation class, this will be natural next step. And from the AST interpreter, which we have implemented in the previous class, we will be moving down to the low level and will implement a stack-based virtual machine. As you can see, this class has all...
That's interesting. This is you want to go into the roots of this. It makes a lot of sense. California use it. Interesting. Look at it. It's followed by Matthias Binds. 2023. Explore, compile, engineering path, and all that kind of stuff. Jesus, French those guy, bro. Okay, building an interpreter from scratch. Okay. Alright, okay, interesting. Okay, good, awesome. Holy moly. And here is now building a parser here.
Hi and welcome to the first session of the Building a Parser from Scratch class. My name is Dmitry Soshnikov and I'll be teaching this class. And just to set the agenda, this is purely a practical class, right? We will have just a few amount of theory.
Exactly, tokenizer model, parsing model, an abstract syntax tree, predictive parser, recursive descent. So you are
in this
now
class
going
related to
into
parsing,
the root.
but most of the videos will be actually practical exercises, building a parser from scratch. And we'll be building a parser for a full programming language similar in syntax to Java or JavaScript.
Similar to syntax to Java and JavaScript, binary operators, logical operators, branch, if-else expressions, loops, functions declaration parsing, lambda anonymous closures, operators precedence, parsing class and model, property access, and function calls. Moly moly.
And as you can see, token has type and the value, parentheses, and for us, and in theory, so we have the languages.
Okay, but I do think this go a little bit beyond of what I want to actually learn, you know?
Yes. And a parser is
yeah, that go a little bit beyond
into expression format, which is also nothing but the AST. And it will show how to transform different types of AST between each other. So
good. Go beyond the scope of today's video. Absolutely. I do find that it's quite interesting. And state that when control is transferred to ECMAScript executable code, control is entering an execution context. Control is entering an execution context. While your concept understanding has a merit, execution context is more precisely defined as containing a specific components. Okay, the lexical environments, the variable environments, the this binding and the scope change. You might be thinking of the concept you're describing. What a function can have access to is more accurately called scope or lexical environment. So the scope is the current context of execution which values are visible. But in any case, you are describing here is this characteristic is best described as execution context of functions. Also have another characteristic beside their scope that influence what they can have access. Okay. Okay. So besides of what a function can have access, exactly described as scope, okay, this characteristic is best described as execution context, and it is exposed to the function via the this keyword. So scope is static and contains a fixed set of variables available at the moment and location you define a function, but the function execution context is dynamic, which is another characteristic of that. Okay, no, my bad. Okay, you say to say that what a function can have access. So besides what a function can have access, okay, is a scope. All right. Another characteristic or feature, this characteristic is described best as execution context. Another feature is described as an execution context. But what this feature is, bro, scope is static and contains a fixed set of variables available at the moment of the location you define a function. But a function execution context is dynamic, entirely depending on how it is called. So this is not a fixed characteristic of a function based on the function's definition, but rather a dynamic characteristic that determines each time that the function is called. So is the execution context. So one way of thinking about the execution context is that it's tangible object whose properties are made available to the function while it executes. Compare that to scope, which can also be thought of an object, except the scope object is hidden inside of the JavaScript engine. It is always the same for that function, and its properties take the form of identifier variables available inside the function. Yeah, and its properties take the form of identifier. Yeah, wait a single moment. JS engine, it is always the same for that function. And its property takes the form of identifier variables available inside the function. So you get this, right? So you get the classroom, you get the study, right? And when you call this, okay, oh, it makes sense. So teacher here is now creating so the function study creates now a closure over teacher, okay? But this is what the French does. It's now described as the execution context. It's now dynamic. It's depending on how this function is called, okay? So the outer classroom functions makes no reference to a this keyword. So it is just like any other function we have seen so far, but the inner study function does reference this, which make it a this aware function. In other words, it is a function that is depending on the execution context. So when you read this, is that wherever this is being called, all right, the function is depending of it is in other words, so that function, okay, so it is a function that is depending of its execution function. It is a function that depends on its execution function, okay, of its execution context. Study is also close over the teacher variable from its outer scope. The inner study functions return by classroom Kyle. It is assigned to a variable called assignment. So how can assignment, aka how can assignment, which is this, how can assignment, aka study with study, be called? So assignment is this. Kyle says the study is undefined. Oops. In this snippet, we call assignment as a plain normal function without providing it any execution context. Since this program is not in a strict mode, chapter 1 strictly speaking, context-aware functions that are called without any context specified, default, the context to the global object is windowed in the browser. As there is no global variable named topic, and thus no such property on the global object, this.topic resolved to undefined. So now consider is this. Okay, so here you say, hey, homework. Now when I assign that as a function here, and then I call that. So a copy of the assignment function reference is set a property of the homework object, and then it is called as homework.assignment. But a copy of the assignment function reference is set as a property of the homework object. But a copy, and when you copy objects, which is our functions, they are now assigned that by a reference. A copy of the assignment function reference is set as a property on the homework object, and then it is called as homework.assignment. That means this for that function call will be the homework object. Hence, this .topic resolves to JavaScript in this case. Lastly, so when you have now this, the assignment here, other topic is topic, and then you pass now this objects, and the third way to invoke a function is with the call method, which takes an object's other homeworks here to use for setting this reference for a function call. The property reference, this is for setting the this value, which is the context execution. So what is a context execution? A third way to invoke a function is with the call method, which takes an object other homework here to use for setting use this reference. Let me put it this way here. I do think is this exactly. And then, all right. Yeah, I just want to be aware of this. So it means because I want to pervert this. Look at that. that behaviors you want to impose or try to, or that behavior you want to set in somebody, whatever it is. No, because yeah, this is might be good for you, or whatever it is, or good intentions or not. It's not effective. It's not durable because it doesn't come from them. It will here. It's another technique, but I don't invite it. I don't want to do that. Ella tiene una máquina ahí con ella. espresso coffee. And we're back. Okay. Just going to continue to read this. All right, let's going to continue to read this. Okay. But again, this is what this is talking about. All right. One misconception of this, that is, hey, is that the function, this refers to the function itself, which is clearly not. The other is that because of how this works in other programming languages, another misconception is that this point, the instance that a method belongs to, and both are incorrect. And it is because despite that the function, and it is all about the function here. This is, so the closure and the this is just talking about from the function point of view. Whereas the iterable is talking from the point of how you can consume data and what is the end goal of the vast majority of programs out there, which is, well, consume and process large amounts of data so we can act and take decisions based on that. Okay. So we look about the closures, and we also look about the this keyword, which is similar to now function, have the characteristic of a scope. Okay, as discussed previously, when the function is defined, it is attached to it is enclosing scope via closure, and this is attached. It is attached to it is enclosing scope via closure. But as long as you have a reference to that, right? So scope is a set of rules that control how variables, how reference to variables are resolved. This is one of the characteristics here of the function, part of the anatomy of the function. And the other part is how, and the other part is, so one of them is the scope, all right, which is this set of rules to determine how reference to variables are determined or are resolved, okay? And the other is what values can have access to, all right? Or this is described as the execution context, and it is exposed to the function via the this keyword. So a scope is static and contains a fixed set of variables available at the moment and location you define a function. But a function execution context is dynamics. It's entirely depending on how it is called, regardless of where it is defined or even called for. So that this is not a fixed characteristic of a function based on its definition, but rather a dynamic characteristic that's determined each time the function is called. So this value or this characteristic of the function, known as the execution context, is entirely depending on how this function is being called. Okay, so this is to say, besides what a function can have access or scope, another feature is described. Exactly, another feature is the dynamic aspect beside what a function can have access, scope. Another feature in function is the dynamic aspect of what it can have access at runtime, or when it is called. Is the dynamic aspect of what it can have access when it is called via the this keyword. So the anatomy or the functional anatomy, the features anatomy of a function in JavaScript is a closure and the execution and the execution context. So that you could say that the anatomy includes closures, execution context, which is a dynamic this binding, and context-dependent object reference. These works together to make JavaScript functions incredibly flexible, and they're not just reusable code blocks, but carry their environment with them while also adapting their calling context. This is what we will have, for example, the call, apply, and bind. When we can pass now is a reference that these functions can have access at call time when we call this. So when you create now a query function, it makes a lot of sense for us to do that kind of stuff. So regardless, if we, for example, want to implement a query function here, briefly, right? If we do to implement is a query function, which is, hey, no matter how many arguments I pass to this function, whether it is in, let's say query, right? So the goal of this function is to say something like this, all right? So no matter how many arguments we pass to this function, when we call them, we want to do something like this. You know, this is function one, so function one with these parameters or these parameters, right? But what do we care about here is how the function is being called, right? Is how the function is being called. So for example, is the query function, and implement a query function here like this, right? So querying is a useful technique using JavaScript applications here. Wait a moment. All right. It's a useful technique in JavaScript application from the functional programming, which say, hey, query, all right, I'm going to receive as the arguments, and I want to expect now is, and I want to expect to return is also is a function, all right? Here, I want to expect now to return is a function, call as a function with any type that we're receiving here. So we expect to get is these functions or these collections of arguments, all right? We expect to get these collections of arguments, and we expect to return is now the value here. So we're gonna return is now a functions that is gonna call that. So here, because of this point here, right? Query join. We're implementing now a query function. By query join, we're gonna get all of this here, and we expect now to say, hey, I want to is print all of this as it is, right? So no matter how I call this function here or here or here, all right, I do expect that, right? So I'm gonna receive is now these functions with all of these arguments, okay? And no matter how I call it, all right? So no matter how I call this function, I want to expect all of this as it is. So a good example is to say, hey, so because the order in which the order in which the calls happens is irrelevant here. I just wants to call them, all right? So I want to verify if I receive is the arguments at that particular moment, all right? So I do need to check is what is the length of this? Okay, so what is the length of the arguments that I'm receiving? And based on that, I'm going to now call these functions as it is, right? As it is. So I need to is take is the length of that, and then I'm gonna call this function as it is. So because I do need when I call that, and because here is creating is now this close over is the function, all right? Because I'm creating is a close over the function here, I want to check that if the lengths are, so if the number of argument match, I want you just to call them. If it's not, I want us to now is call this again in a recursive way, okay? And then pass the next, exactly, call this. So just bound the query with args and per fields, all right? Which I'm going to pass is the value of this, which will be contained is now the object at this, which will now contain is this by the time I call this, followed by the arguments. And the other is this. So if I do have is the number of argument match, okay? So I want to call this with all of the arguments. If it's not, then I want is to now call this, all right, with all of the missing arguments that I'm gonna receive. So call this with now the this, which is in this case is contextual to the function in itself, all right, similar to the args and the missing args. So here we're passing is all the arguments that it needs to spread that argument, which is an iterable, and then receiving is the missing arguments, and check that again. And check that again. Hey, is the argument that I'm receiving is greater or equal to the length? All right. If it is, okay, it means that we have all of them that we can actually call them. And this is part of the JavaScript coding practices here. Okay. Okay. And implement a query placeholder here. Queryable. Passing each parameter in query calls. 4 million operations per second. Benchmark were performed on i7 8-core Arch Linux laptop with 16 gigabytes of memory using Node.js version here 10. Curable. Passing all parameters in one call. Passing all parameters in one call. That's interesting. But so even though that I'm here, okay, I know that I need to check is the length of that. If I receive is the length in the next call, and if that is greater than that, all right, on the next call, which is return now is this function, let's say query it. Okay, so what I'm doing here is to say, hey, I'm going to define now. So this is spec to a function call. So querying join, all right. So these functions that I'm going to define here called query, all right, that expect to get some arguments here. Just in this case, I'm going to call this args, all right, and spread all of that. Okay, so when we do this, we say, hey, iterate through all of this, all right, and spread that into this call, all right, or to get all of these arguments as an array like. Okay, in this case, as a function, this is how it works here, the spread operator. And then we say, hey, args, okay, if the args.length is greater or equal to the function.length, and here we are now using a closure, okay, which means that if we already have all of the arguments here, what I want to do is to say, all right, now call this, which is, remember this function that we pass here? I want to call this, all right, with this value, that by the time that I'm calling this query function, all right, this value, which is per reference, okay, you can assign this. The benefit of the this-aware function and their dynamic counting is the ability to more flexible reuse of a single function with data from different objects. A function that closes over a scope can never reference a direct scope or a set of variables, but a function that has dynamic this context aware can be quite helpful for certain tasks. But in this case, what I'm saying is that this value, all right, which is dynamic, which is whatever you have now by the time that you call this function, all right? That I don't know why is this, what this value it is, but I also going to pass is all of the arguments here. So you can call that. However, if it's not, so what I'm gonna do is to, whether it's to bind them, this is one of them, or to return another function that actually calls them. You say, hey, return is another function. You can say return is another function here, which is, yeah, return is another function here, where in this case, I want is to now collect is the missing arguments, and they now call query function. So in other words, you say query, all right? I want to is call with this value here, and here by the time I call this function, I am going to now receive is the missing arguments, all right? So spread the missing arguments here, or do this, it's a spread is the arguments that I get from the previous function calls and the missing arguments that I'm getting here, all right, as well. And this is what I'm gonna, and then I'm gonna call this query call. No, I want to call this. Exactly, I want to invoke these functions and check that again. Not for real? What, did you submit this? Okay. Okay. That makes quite interesting. No problem. No problemo. No, it does not. And I need to return this there. Yeah, I do think that I need to return that. And here's this missing arguments here. So let's walk through this. I am defining as a querying function that I'm going to receive as a function, and all what I want to do with this query is to say, hey, we want is to is no matter how I pass the arguments, all right? And in this case, so no matter how I pass these arguments, I want to, once I get all the arguments, which is something that eventually you're going to have, I want to actually is execute all of that as expected, right? So it means that if, for example, by the time that we call this query function, we already have all of the arguments, all right, that we expect here, based on this example. If we do have, then I want is to call that function with all of the arguments, right? But for some reason, if we don't have all of them, we need to wait for this. We need to wait for this. We need to wait for these arguments here. Exactly. We need to wait for these arguments here. And that means that by calling is this function here, we say, hey, do we have them, right? Because I'm receiving is the missing argument here, and what I do is say, hey, call now query with this, with the arguments that I already have, plus the missing arguments, and then by the time that I call this function here, and by the time that I'm calling this function, which is dynamically, all right, I want to pass now is the diff reference to this function, and then ask the question again. And then ask the question again. But here I am calling is that. I am returning is this call. I am returning is this function call. I am returning is this function call. I am returning is this function call. Yeah, because I am returning is this function call. Except I am returning is this function call. It's because I am returning is this function call. So I know that I need to is to verify somehow that the length of this function is greater is if we already have that length, right? If we already have that argument length. So the way to do that is by saying, hey, this query function where I'm going to receive is this arguments, okay? If the first time we receive that, we already have all of them, okay? So whether it's greater or equal, so no matter how many arguments we receive, we do only want this set of arguments. It makes a lot of sense. To say, hey, dot length here, all right? And if it is, so what we're going to do is to, okay, if we return this function dot call, we are returning is this execution. So we're returning is the execution back to the function that where it was called here. So we are returning is the function call. We are not only calling it, we are returning. And when we return, it will call now this. So when you say this and the arguments at that moment. However, but if we don't have them, okay, we need to wait for those arguments here. And the way to wait for those arguments is by defining as a function, all right, whatever name of the function is, with the missing arguments, all right, with the missing args, okay? And this function is something that is going to expect, or is going to say, hey, I want to call now the query function with the this value that you have at that moment, okay? Whatever dynamic value you have at that moment, followed by the arguments that I have, plus the missing arguments. Exactly, plus the missing arguments here. So if I do this, right? What happened is that I need to call those functions. And I need to call those functions because, well, I need to return as a function here because I'm gonna call that, all right? And in this function call, I'm going to is return is this function call with these arguments, and then ask that again. And again, I know that there is nothing wrong with this if I don't get it at the first moment. Okay. Query join is not a function. Oh, because I'm not returning that. Exactly. I'm not returning that. You are right. I'm not returning that. And now I get this. I know I cheat here. I know I cheat here, but I'm just starting to develop this sense of how not the JavaScript engine see things, especially with closures. All right, and here we are creating is a closed query is a function is a close over function variable. All right, and he was saying is we already have all the arguments. Good. No, call that function and return that. Right. So whatever value that you get here, exactly, that's exactly what we're doing. So wherever value that this function calls generate, I want to give it back. I want to return that. Makes sense. However, if we don't have all the arguments, we have to wait for them. And the wait for them is by the next function call, which is this. So by the time that you call this function again, and I receive these arguments, the question is that, do we have all the arguments here? And the way to know that is by saying is, hey, let me call this function with all of these arguments, all right? And see if we already have them. Okay, if we're not, we need to continue to call the next one. We need to wait for the next arguments here. Makes a lot of sense. We need to wait for the next arguments here and then call this function again until we get is the enough arguments here. Holy moly, bro. That is a mind-bending stuff. That is a mind-bending stuff, especially from the functional programming. And perhaps we are a little bit further to this track, but that'll be all for this video. Take care. Bye-bye.